Welcome back to the Real Number System. In this video, we're going to talk about section 7.1, and we're going to look at what are called terminating decimals. So let's get started. The word decimal comes from the Latin decim, which means 10. We have a decimal number system that tells us that we have the base 10 for our base. Every place of a decimal may be named by its power of 10. So let's look at the number 12.61873. I'm going to focus on the decimal places. The 6 is in what we call the tenths place. The 1 is in the hundredths place. The 8 is in the thousandths place. The 7 is in the 10,000ths place. And the 3 is in the 100,000ths place. This decimal would be read 12.61873, or we can read this decimal as 12 and 61,873 hundred thousandths. So notice two things. When I read the decimal, I said 12 and, that and symbolizes the decimal place. And then I also read it and I used the hundredth thousandths place, that last decimal place. Now we think about our decimal with powers of 10. So again, let's consider this same number, 12.61873. Our 2 is in the ones place, or 10 to the 0. The 1 is in the tens place, or 10 to the first power. And if we keep on moving left in our places, our powers of 10 increase by 1. When we move to the right of the decimal place, we now have fractions. The 6 is in what we call the tenths place. So this would be 1 over 10, or 10 to the first. The 1 is in the hundredths place. So that would be 1 over 100, or 1 over 10 squared. The 8 is in the thousandths place, 1 over 10 cubed. The 7 is in the 10,000ths place, 1 over 10 to the fourth. And the 3 is in the 100,000ths place, 1 over 10 to the fifth. If I write this in expanded notation, I begin with the tens place, the 1 that's in the tens place. So we have 1 times 10 to the first. Then move to the right, we have the ones place, so 2 times 10 to the 0, 10 to the 0 is 1, plus 6 times 1 over 10 to the first, plus 1 times 1 over 10 squared, plus 8 times 1 over 10 cubed, plus 7 times 1 over 10 to the fourth, plus 3 times 1 over 10 to the fifth. Now I can also write this using negative exponents. When I move my base from the denominator to the numerator, that power becomes negative. So if we have 12.61843, our 1 is in the tens place, so 1 times 10 to the first. The 2 is in the ones place, so 2 times 10 to the 0. The 6 is in the tenths place. That was 1 over 10 to the first, or I could write that as 10 to the negative 1. So I'd have plus 6 times 10 to the negative 1. Plus 1 times 10 to the negative 2, that's our hundredths place. Plus 8 times 10 to the negative 3, that's the thousandths place. Plus 4 times 10 to the negative 4, that's the 10,000ths place. And then last we have 3 times 10 to the negative 5, that's our 100,000ths place. Decimals can be introduced to children with concrete materials like our blocks, flats, longs, and cubes that we looked at earlier this semester. The cubes we called units earlier this semester, but we're going to call them cubes here. Remember, 10 cubes would make one long. 10 longs make a flat. And we didn't talk a whole lot about the blocks, but 10 flats make a block. Now, if I think about the 10 cubes equals 1 long, what that tells me is 1 cube is 1/10 of a long. Or 1 long is 1/10 of a flat. And 1 flat would be 1/10 of a block. I can also think about longs and blocks. Now it would take 100 longs to make a block, because 10 longs make a flat and 10 flats make a block, so 10 times 10 is 100. That tells me that a long is 1/100th of a block. There would be 1,000 cubes in a block, so 1 cube is 1,000th of a block. Now let's suppose that a long is representing our unit. And so a cube is 1/10 of a long, so the cube would represent 1/10 of a unit, or 1/10. So if I use longs and cubes to represent 5.4, the 5 is my unit, so I would have 5 longs. The 4 is in the tenths place, and that would be 4 cubes. Let's look at another. Let's suppose that a block represents a unit. And let's use our blocks, flats, longs, and cubes to represent 2.235. So my block is my unit. That means that my flat is 1/10 of the unit, or 1/10 of the block, because there are 10 flats a block. So the long would represent 1/100th of a unit, because there are 100 longs in a block. And a cube would represent 1/1000th of a unit. Our units are 2, so we'd have 2 blocks. The tenths place has a 2, so we also have 2 flats. The hundredths place has a 3, so we have 3 longs. And the thousandths place has a 5, so we would have 5 cubes. Now we can convert our fractions to decimals. And we have a table, you see it in your notes and on your screen, that shows examples of decimals, their fractional meanings, and some common fraction notation. Now let's suppose we have something like 25/10 and we want to convert to decimals. As I look at converting this to a decimal, I want to think about powers of 10 in the denominators of my fractions. Now 25, I'm going to rewrite as 20 plus 5. I chose the 20 because it's a multiple of 10. Pull your fraction apart. So we have 20/10 plus 5/10. Now notice the denominator went under each piece of that numerator. 20/10 is 2, and I'm going to bring across the 5/10. Now yes, 5/10 does simplify. It simplifies to 1/2, but I want to keep the denominators of my fractions as powers of 10, because this tells me for this problem, we're looking at the tenths place. So I have a 2 in the ones place, point, and then the 5 in the tenths place. Let's look at another one. In part B, we have 56/100. 56 I can rewrite as 50 plus 6. Again, I chose the 50 because it's a power of 10. Pull your fraction apart, so we write 50/100 plus 6/100. I want to be sure that my denominators stay as powers of 10. Now 50/100 will simplify. 10 goes into 50 5 times, and 10 goes into 100 10 times. So that's going to give me my tenths place. Then bring across the 6/100, that's your hundredths place. Now notice there are no ones here, so I have a 0 for that ones place. And so my answer would be 0 in the ones place. I have 5/10, so that's 5/10, a 5 in the tenths place. And then the 6/100, that tells me I have a 6 in the hundredths place, so 0.56. Let's look at the next one. We have 205/10,000. 205 we rewrite as 200 plus 5. Then pull your fraction apart. We have 200/10,000 plus 5/10,000. Now, by the way, I chose that 200 again because 200 is a multiple of 10. I want to make sure my denominators of my fractions have a power of 10. But if I can simplify to a different power of 10, I always want to do that. So 100 goes into both 200 and 1,000. 100 goes into 200 2 times, and 100 goes into 10,000 100 times. Bring across the 5/10,000. Again, make sure you have powers of 10 in your denominators. We don't have any ones here, so I have a 0. I don't have any tenths, so I have a 0 over 10. Then I have 2 over 100. I don't have any thousandths, so I have 0 over 1,000. And then bring across the 5 over 10,000. So I have a 0 in the ones place. Don't forget your decimal place behind the 0. A 0 in the tenths place, a 2 in the hundredths place, a 0 in the thousandths place, and a 5 in the 10,000ths place. And so my decimal is 0.0205. Now, if your denominator is not a power of 10, we rewrite our fraction so that the denominator does have a power of 10, and that will allow us to convert the fraction to a decimal. Let's look at some examples. So we have 3 over 5. I want to be sure that I have a power of 10 in the denominator. Well, to get 10 in the denominator, I can multiply the bottom by 2. If I multiply the denominator of a fraction by 2, remember from chapter 6, I also have to multiply the numerator of a fraction by 2. 3 times 2 gives me 6 in the numerator, and 5 times 2 gives me 10 in the denominator. Now notice there are no 1s, so I have a 0 in the ones place plus 6 over 10. So we have a 0 in the ones place, your decimal place, and then notice the 6 is in the tenths place because we had 6 over 10. So my decimal is 0.6. Let's look at another. Let's suppose we have 7 over 2 to the 4th. Now I need powers of 10 in my denominators. To get a power of 10, my power of 2 and my power of 5 have to match. So I'm going to multiply the denominator by 5 to the 4th so that my power of 2 and my power of 5 match. If I multiply the denominator by a power of 4, I also have to multiply the numerator by a power of 4. I'm going to bring down that numerator, 7 times 5 to the 4th. Now the 2 and the 5 have the same power, so I can put them in parentheses together, and they are multiplied, and put the power, that 4, on the outside. 5 to the 4th is 625, and 2 times 5 is 10, so I'd have 10 to the 4th in the denominator. Use your scratch paper and multiply 7 times 625. You get 4,375, and I bring down that denominator of 10 to the 4th. Now, as I try to rewrite the fraction as a decimal, remember we look at our powers of 10 in the bottom, and I want to look at multiples of 10 in the top. So 4,375, I'm going to write as 4,000 plus 300 plus 70 plus 5. And 10 to the 4th is 10,000. Pull your fraction apart, so you have 4,000 over 10,000, 300 over 10,000, 70 over 10,000, and 5 over 10,000. When I simplify each of these fractions, I want to simplify so that I keep a power of 10 in the denominator. Well, 1,000 goes into 4,000 and 10,000. 1,000 goes into 4,000 4 times, goes into 10,000 10 times. Now notice I put the 0 here because I don't have anything in that ones place. Then 100 goes into 300 3 times and into 10,000 100 times. 10 goes into 77 times and into 10,000 1,000 times. And then we have 5 over 10,000. Notice as I was simplifying each of these fractions, I was thinking about powers of 10 like 1,000, 100, and 10. So we have a 0 in the ones place. Don't forget your decimal place behind the 0. A 4 in the tenths place, 3 in the hundredths place, a 7 in the thousands place, and a 5 in the 10,000s place. So 0.4375 would be our answer. Part C. Again, to have a power of 10 in the denominator, that's what I need to write this as a decimal, I need the power of 2 and the power of 5 to match. That means I need to multiply the denominator by 5. That will give me a 5 to the 3rd in the denominator. If I multiply the denominator by 5, I also have to multiply the numerator by 5. 1 times 5 is 5. And when I multiply the denominators, I get 5 to the 3rd. Bring down the 2 to the 3rd and add the powers of the 5. That gives us 5 to the 3rd. Because my 2 and my 5 have the same power, I can write them in parentheses with the power on the outside. And 2 times 5 is 10, and bring down that third power. 10 to the third is 1,000. Now notice here, there are no ones. There's nothing in the tens place, so I have 0 over 10. I have no hundredths, so I have 0 over 100. And then I have 5 over 1,000. So we have 0.005 for our answer. Look at part D. I need to rewrite 125 as powers of 5 and 2. Well, 125 is 5 to the third power. If you need to, make a factor tree off to the side. 125 would be 5 times 25, and 25 is 5 times 5. That's where the 5 to the third comes from. To write this as a decimal, I need a power of 10 in the denominator. To get that power of 10, my power of 5 and my power of 2 have to match. So I'm going to multiply by 2 to the third. And if I multiply the denominator by 2 to the third, I also have to multiply the numerator by 2 to the third. 2 to the third power is 8. And in the bottom, I can write those in parentheses with the power on the outside because the 5 and the 2 have the same power. 3 times 8 is 24, and 5 times 2 is 10, so we'd have 10 to the third power in the denominator, and 10 to the third power is 1,000. Rewrite 24 as 20 plus 4. Again, I'm thinking about multiples and powers of 10. Pull your fraction apart, so we'd have 20 over 1,000 plus 4 over 1,000. To simplify 20 over 1,000, I want to think about a power of 10 that goes into both. Well, 10 goes into 22 times and into 1,000 100 times. And bring down the 4 over 1,000. I don't simplify any further because to write this as a decimal, I want to keep powers of 10, like 10, 100, 1,000, 10,000, and so on in that denominator. There's nothing in the ones place. There's nothing in the tenths place, so I have a 0 in the tenths place. I have a 2 in the hundredths place and a 4 in the thousandths place. So 0.024 or 24 thousandths would be my answer. Let's look at one more. 7 over 50. Well, 50 I know is 25 times 2, and 25 is 5 times 5. So I could rewrite 50 as 5 squared times 2. When I'm writing this fraction as a decimal, I need a power of 10 in the denominator. To get that power of 10, the power of 5 and the power of 2 have to match. So I'll multiply the denominator by 2, and if I multiply the denominator by 2, I also have to multiply the numerator by 2. So 7 times 2 is 14. And in the denominator, I'd have 5 squared times 2 squared. Add the powers of 2 to get the 2 squared. Bring down the 14 on top. 5 times 2 is 10, and I can multiply the 5 and the 2 because the powers are the same. And 10 squared is 100. Rewrite 14 and pull your fraction apart. So we'd have 10 over 100 plus 4 over 100. 10 goes into 10 one time and into 100 10 times, and bring down the 4 over 100. We have nothing in the ones place. Don't forget your decimal point. We have a 1 in the tenths place and a 4 in the hundredths place. And so our answer would be 0.14 or 14 hundredths. Terminating decimals are decimals that can be written with a finite number of places to the right of the decimal place. Now, to know whether or not we have a terminating decimal, we look at the denominator and we look specifically at the prime factorization of the denominator. The only prime factors we can have in the denominator are 2's and 5 if our fraction can be written as a terminating decimal. So let's decide if our fractions can be written as a terminating decimal. We have 7 over 8. I want to focus on that denominator. Do I have just 2's and 5's in the prime factorization of 8? Well, 8 is 4 times 2. 4 is 2 times 2. Do I have 2's or 5's and nothing else? Yes. And so yes, 7/8 can be written as a terminating decimal. Look at part B. We have 11/250. Again, I want to focus on that denominator. Can 250 be written as a prime factorization with only 2's and 5's? Well, 250 is 25 times 10. 25 is 5 times 5, and 10 is 5 times 2. Do I have only 2's and 5's in that prime factorization? Yes. And so 11/250 can be written as a terminating decimal. Look at part C, 21/28. Find your prime factorization of the denominator. 28 is 4 times 7, and 4 is 2 times 2. Do I have only 2's and 5's in the prime factorization of the denominator? No, this one has a 7, and so this one cannot be written as a terminating decimal. Look at part D, 37/768. Find your prime factorization for 768. Well, this is an even number, so I know 2 divides into it. I've used my scratch paper, and 2 goes into 768 384 times. Now, 384 is an even number, so 2 divides into it. I used my scratch paper, and 2 goes into 384 192 times. 192 is even. 2 times 96 will make 192. 96 is even. 2 times 48 gives us 96. 48 is 6 times 8. 6 is 2 times 3. 8 is 2 times 4. And 4 is 2 times 2. Does my prime factorization have only 2's and 5's? The answer is no. And so here, we cannot rewrite 37/768 as a terminating decimal. Our last topic in section 7.1 is ordering our terminating decimals. So to order our decimals, we first line up the numbers by place value, and we're going to append zeros at the end if necessary. Now, appending a 0 after a decimal point doesn't change the number. Then our second step is we start at the left, and then we find the first place where the face values are different in that place. And third, we compare the digits. The digit with the greater face value in this place represents the greater of our two numbers. So look at example 6. First, rewrite your decimals so you line up your places. I'm going to line up the decimal places in each of my numbers. Now notice 6.21 only has 2 decimal places where all of my other numbers have 3. So I'm going to append a 0 to the end of 6.21 so that all of my numbers have the same number of decimal places. Appending a 0 after the decimal place doesn't change the number. Then I'll look at the ones place. The ones place is all the same. Move to the tens place. The 2 is the smaller number in the tens place, and I have 3 numbers that have a 2 in the tens place. So I move to the hundreds place. I compare the digits in the hundreds place for these 3 numbers. I have 1s and 3. The 1 is the smaller digit, so I'm going to compare the numbers that have a 1 in the hundreds place. And I move to the thousands place. 0 is the smaller digit in this thousands place. So 6.21 would be the smallest, then 6.214, the next 6.232, and last 6.537. Let's look at one more. First, we need to line up our places. Notice that as I am writing these and lining up the decimal place, I append the zeros at the end to the right of the decimal place to be sure that I had the same number of decimal places to help me compare my numbers. My ones place is the same in all 5 numbers, so I move to the tens place. The smallest digit in the tens place is a 2, so I'm going to compare the numbers that have a 2 in the tens place. Move to the hundreds place. 0.200 has a 0 in the hundreds place. That is smaller than 0.25 in that hundreds place. So 0.2 is the smallest, then 0.25. Now next, the 3 in the tens place would be the next smallest in the list. So I'm going to compare these two numbers that have the 3 in the tens place. They both have a 4 in the hundreds place, but in the thousands place, that 0 is smaller than the 4. So 0.34 would be next, and then 0.344, and finally 0.67.